Alright, so here we are with our properties of functions. We're doing day 1 today, and we are going to analyze these functions. So, you're going to get a worksheet, or access to a worksheet in a minute, that has these functions on it. You're going to have to match each of the functions the image is. We are actually going to do the identity function together on the next slide, but here are what you're going to match up. So you're going to match up your identity function, which is just the y equals x, the squaring function, which is also your quadratic function. Then we have your cubing function, which has a power of 3, so x to the power of 3. After that, you'll see an image of a reciprocal function, and that's going to be 1 over x. Looks like there's a tiny little hiccup on that line, but it's just 1 over x. The next one you'd see and match up is going to be e to the x, which is an exponential function, and we'll go over a lot more with that later. And then also logarithm function, so natural log of x here. So each of these will be pictured on your worksheet, and so you would just match up. You can see here on the next slide of what it's asking you to do. So you can see that it's going to ask you the name of the function, and then the equation of the function, and then we're going to talk about each of these items, which were mentioned in the notes the other day. So taking a look at this first one here, again on your worksheet you will have problem 1 there. This is the identity function, at least according to our textbook, but it is also known as the linear function. So either way, the equation is f of x equals x. Whoopsie, hi, lots of things there. F of x equals x. And so we can go ahead and fill out what's happening. So remember that your domain is the x's, and so if we imagine how far to the left it's going to go and how far to the right it's going to continue, turns out it's forever. So your domain is going to be that x's are between negative infinity and infinity. And if you remember back to our Algebra 2, or maybe your Algebra 2, whatever you took, you may also write it as all real numbers, because we do in fact know that there are in fact imaginary numbers or complex numbers. So again, that R, or capital R, does not stand for range. It stands for the phrase all real numbers. All right. Then we have our range, and remember that your range are your y values, and so when we write our range, there's going to be a y involved. You'll see that we've got the range going all the way up to infinity and also all the way down to infinity. So when we write that in here, we're going to write that y is between also negative infinity and infinity. So again, this is analyzing a graph. All right. After that, we're looking for continuity, and so this is where you would say it's either continuous or not continuous. And since it's continuous, we don't need to necessarily identify how discontinuity or what discontinuity it has, because it's just continuous. So again, you don't pick up your pencil, so it's continuous versus discontinuous. Then we have our increasing and decreasing intervals. So this one's interesting, of course, because it just increases the whole time. So just as we did in our domain, we can say that it increases from negative infinity to infinity. Or, of course, we can even in fact say that it increases on all real numbers. All right, the next one here is going to ask you if it's bounded or not, and then if it is, you're going to identify what those bounds are. In this case, again, not bounded. So we're going to just write not bounded, and so we don't really need to elaborate much. All right, the next piece is, are there asymptotes? And so you would give the equations of those, but in this case, we do not have any asymptotes in our identity function. It's asking now if there's symmetry, so basically it's asking, do you see an odd function or an even function? And in this case we have an odd function, because it turns out x is to the power of 1, technically. So in that case, our symmetry is rotational symmetry. And remember that it's given to be at 0, 0, but we may as well be as specific as possible. So rotational at 0, 0. And then they're asking for our maximums and minimums, and we don't have any, because they're either infinity or not there. So in that case, that is none. All right, so that's what you're going to do for the rest of the equation. So as you look at these previous ones, again, you're going to match them and write in their name and their equation. And then you're going to talk about their bounds and increasing and decreasing pieces. All right, so good luck.